All right. Hello, everyone. My name is Kiril Matev, and I am a technical evangelist with Infragistics. It's 11 a.m. On the East Coast, so we'll start the webinar. Thank you for taking the time to attend this webinar. I hope it'll be interesting for you. Indeed, it is a very interesting topic. WPF performance has always been a key concern for many developers. So I hope you'll be able to find some interesting takeaways from this session. What I'll do is I'll go through some general guidelines on how to have a well-performing WPF application on the UI side. I mean, obviously, on the data, in the data layer and in the business layer, there's many things we can do, but as our focus today is on the UI layer, this is what I'll spend most of my time on. What I'll do afterwards is I'll introduce a lot of the improvements and the ways you can squeeze out extra performance from our WPF grid control, the XamDataGrid control, which many of you may be using. As you well know, the more sophisticated the control in WPF is, the more difficult it is to get it to perform quickly due to the inherent sophistication, let's say, of the WPF framework, which is very customizable, but it's something that you need to be careful with, especially when performance is concerned. So I'll go through some slides telling you about the general guidelines on how to have a well-performing UI layer, and then we'll focus on the XamDataGrid with samples as well. Most of the samples, actually all of the samples which I'll be showing you today, are already available on my blog. I will be posting this slide deck and also the samples with links to the samples. So everything you will see today, you'll be able to get quite easily from my blog. So with that said, let's get started. All right, so WPF applications are next stage in desktop development, and many developers are now migrating their existing Windows Forms applications and are finding very often a very visible performance discrepancy. Why isn't my grid performing as quickly as it was under Windows Forms? Why is this ribbon control not loading as quickly? So these are the kind of concerns that many developers have, especially when you have very demanding UIs, such as the ones shown here, with 3 screens right next to each other. This is hooked onto a single machine, so you can imagine the kind of memory load, the kind of applications that are running on such systems. And of course, users always expect applications to perform better and better, and they do not tolerate a step down from the performance levels that they've seen running their MFC and Windows Forms applications, which have been very successful, but unfortunately not very flexible. So we do need fast applications for the demanding desktop scenarios. With WPF, this has been a challenge on some days, especially because WPF is just so rich and so customizable. So very easily you take one step off the beaten path and you find that performance is degrading quite rapidly. So I'll go over some of the general recommendations on how to make your WPF applications faster. A lot of performance has implications for the way resources are declared. It's always much better to use shared resource definitions. Obviously, you don't want resources being loaded again and again at different points in your application, the same resource loaded again and again. You want to use static resources instead of dynamic ones, because the dynamic ones get resolved at runtime. And although this is very flexible and can simplify your style sheets to a great extent, it's not ideal for performance, because you'll see this as a recurring theme through the session today. You want to move as much as possible away from doing work on the UI thread, because if you're doing work on the UI thread, you're degrading the user experience. So using static resources rather than dynamic ones may make your source code more voluminous, longer, more complicated to understand, but will give you a few extra bits of performance. And very often when you're, for example, binding a template to cells in a grid, and when you have maybe 30 rows by 30 columns, you can imagine the number of cells visible. And in this case, every little helps. So every time you save a bit of, every time you gain just a bit of time because you're using a static resource rather than a dynamic one, this always helps you, especially in bigger controls such as the grid control. And we'll see some examples illustrating that as well. It's very important to keep in mind that styles can have a dramatic impact on performance. We've had a number of cases with customers where the developer builds the application just fine, throws it over the wall to the visual designers who work on the XAML, who work on the resource dictionaries, and the application looks great but performs horribly. And as the designers use Blend, and they don't really realize the effect that their changes has on performance, it makes it very easy for them to set properties which can degrade performance really badly. One of these is setting opacity on elements. When you set an opacity on an element rather than on a brush, the CLR generates a temporary surface for the element every time it is shown. And you can imagine instead of modifying a single brush object, you're setting an opacity on an element which is a part of a template which is generated, let's say, 200 times on a screen. Let's say it's a part of a button or it's a part of a cell template. So it's very important to track closely the work that designers are doing and to benchmark performance often. Also, something that degrades performance really badly are bitmap effects. A single shadow applied on a label in a cell of a grid can have dramatic effects. We're talking multiples of seconds of delay when scrolling vertically using the thumb. And very often we've seen such cases because designers simply aren't aware of the performance impact of their choices. So if you are indeed experiencing performance difficulties after your application was styled, I would recommend taking a look at any opacity settings or any bitmap effects such as shadows or embossing or any such visual gimmicks, which are pretty, of course, but can be applied in better ways in order not to make performance suffer. So these are just some general guidelines. In WPF, always when you're after performance, reduce the number of visual elements, and we'll talk about this more, especially on the UI layer. The fewer visual elements you have, the better the CLR will handle them, because you can imagine there's a difference between having 3,000 elements on a screen and 9,000. So every time you scroll, the CLR needs to measure, arrange each of these elements, and to propagate routed events, to arrange for the layout, and all the record keeping required to keep all these elements alive. So reduce the number of elements. That's the very first advice we always give when there's a performance concern in front of us. Of course, whenever you're visualizing a list of some sort, always use virtualized containers which recycle the elements, and these are, for example, the XamDataGrid, the Xam data tree, and so on. These are all virtualized containers. Refrain from using bitmap effects. I already mentioned that because of its dramatic effect on performance. Set neutral culture on your assemblies using the neutral resources language attribute to prevent the lookup of satellite assemblies. With regards to data binding, it's very important to fix binding errors. Very often styles cause binding errors, especially when you change the name of a column or the name of a property in your view model. Very often your styles just don't follow, and that causes binding path exceptions, which are quite slow. And as I say, one or two may not be so bad, but when you have such a binding error in a template, which is in a cell, visualized in a cell, and when you have 30 by 30 XamDataGrid, you can imagine these delays add up. We always recommend to bind to an IList rather than an IEnumerable, because the CLR generates an IList around the IEnumerable anyway, so that saves you some time there. And when you're adding or removing data from data sources, it's always much better to bind to an observable collection rather than an IList. The converter versus the data template selector debate is alive and well. The data template selector is a very useful facility when you'd like to be very flexible in the way you control appearance, in the way you present your UI to your users. However, it is slower. It makes for very maintainable code. It's very concise, but it is slower, and that's why we recommend using converters, because converters are faster, because they are compiled. They're not interpreted as part of your XAML. And something you need to keep in mind with converters is that every time you scroll, for example, a column into view on the XamDataGrid, the converter will be invoked for the entire column of cells coming in, or for the entire row. All the converters of the different cells will be invoked. And this is something you don't want, of course. It's much better to do all this processing, all the formatting, all the style selection before you bind your data. And we'll see an example of this later on. But this is one of the two mantras really on improving WPF performance, WPF application performance. One, minimize the number of visual elements, and two, do as much as possible before you get to the UI, because if you're doing all this processing on the UI level, you're taking away valuable cycles from the CLR, which can spend those measuring and arranging elements, so you would see a more responsive UI. So, for example, your grid would scroll faster. So this is very important. So, data template selector, use it in controls which aren't, there simply aren't that many instances of them. This will make your code very maintainable, very usable, reusable, very easy to understand. And as long as there aren't too many instances of this style or of this template, you shouldn't see much of a performance issue there. Converters, they're fine. We always recommend to only look at these improvements if there is a problem. There is no need to go overboard at the very beginning, because as you maybe have probably seen, we are in improving WPF performance, we are actually refusing to use some of the conveniences which WPF brings related to Windows Forms. We are doing processing at the back end, just like we did with Windows Forms. We're binding to the direct values. We're not styling at the UI level. We're determining which brushes to use at the view model level in order to prevent this logic from being executed on the UI thread during the actual interaction of your user with the application. So you'll see we are kind of doing a trade-off here. We're making the source code less maintainable, if you can say so, in key places, and it's important to document that as well. And this is something I'll talk about later, because there is an important approach that illustrates this very trade-off, where to get extra performance, you do stuff that's not exactly maintainable, and you need to make sure that your colleagues understand why things are done in a certain way, so they don't optimize your source code into something more maintainable, but which causes worse performance. Right. So I spoke about the converter limitations. For virtualized item controls such as the grid, conversion logic will be invoked for each cell coming into view. So it's much better to do all this formatting and brush setting for the background and foreground coloring at the view model level. Also, something very important for the grid, avoid unbound columns and converters. It's much better to create, let's say you have 3 fields coming in from your database. You will be computing a 4th field. It's much better to compute this 4th field at the view model level than to add an unbound column and compute it with converters in the grid itself based on the values in the other 3 columns. So you're probably already seeing the pattern here. We're trying to move as much as possible away from doing all this formatting and styling work using the grid itself. We're trying to do it beforehand, so the grid doesn't have to worry about it and can have the time to render itself in the quickest possible way. Right. So yeah, so much for the general advice. The XamDataGrid is the most sophisticated control in our tool set. The grid control is always the most sophisticated in any tool set. So how do we speed up the grid specifically? So the smaller the number of UI elements, the better performance. By default, when you bind our grid control to one of your data sources, you will see editors being generated. Let me actually illustrate this very quickly. So I will run one of the samples just to give you an idea of what the cell value templates, cell value presenters look like by default. So here's the application which we're going to be working with. I'm going to open WPF Inspector so I can see the elements which make a part of this. So let's take a look at what this one looks like. Right. Okay, so we're taking a look at how a single cell is rendered. So a single cell, you can see this is the cell value presenter element. It shows us a single value in a cell, and it has 12 elements. This is because WPF is very customizable, and the grid is coded in a way to enable you to create all sorts of customizations. For example, this is a currency editor, so it inserts the currency value, the currency symbol, I'm sorry. It inserts, it formats your value according to your regional settings. It even has spin buttons, just like numeric editors have. So these are not visible currently, but with a single style, you can make them visible because the XAM currency editor is a numeric editor, which has the up and down buttons. So you can see a single cell takes us 12 elements to visualize. So for the whole screen, we have 11,400 elements. And you can see, of course, the screen is full of data. We do have users which have such cases, and they want performance. They want the grid to scroll quite quickly. So how do we improve on that? And let's say, how do we make sure that users get the fastest level of performance when this data isn't even editable? Let's say we don't need to edit this data. It's all read-only. Very often in large, in such big screens with the XamDataGrid, maybe just a few columns are editable. The vast majority of the columns are read-only. Do we need the up and down buttons in such a case? We don't really. So something we recommend always as a first step when you're pursuing performance improvements is to use read-only simplified templates for presenting cell values. This sample includes such a template, and I will benchmark the scrolling speed now and after I switch to the read-only template. So we've expanded all these groups. There's maybe 3,000 records here. So hit benchmark scrolling, and you can get this sample from our website, from my blog, so you can benchmark different settings for yourself and you can see how they impact performance. So as soon as this is finished, we'll have the time it takes for the grid to scroll through this data using the normal styles. So we're getting 12 UI elements per cell, roughly 11,000 elements for the entire screen, and that takes 24 seconds. So if we switch to read-only templates now, which are faster, which are much leaner, you see that the formatting changed slightly. There's no more currency symbols. The values are left aligned instead of right aligned. Of course, this is something you can change quite easily with a simple style setting, but this is just to illustrate we're not using the original style anymore. I'll run the WPF inspector now so you can see the visual element tree again. Right, attached to it. Okay, here we are, and yes. So now we have, instead of 12 elements, we have 3 per cell value presenter. So what we've been able to do is cut down the number of elements by a factor of 4, and we're still showing the same data. So all of this data is now read-only because there's no editor. There's just a simple text block. So you can still do foreground, background styling. You can set colors, setting them on the border element, but you cannot edit. And you don't need to apply this across the whole grid. I'm doing this just as an example. Obviously, some of the columns which you're using will not be read-only, will need to remain editable. But you can still gain a quite significant improvement in performance if you use this cell value presenter style for all of your columns which do not need to be edited. So how many elements are we using up now? 4,700. So we've cut down the number of visual elements by 3. So you can imagine this gives the CLR much more breathing room to work when the grid is scrolling. So let's see how this works out. I'll minimize this. We've now switched to read-only, and I will run the benchmark scrolling again. So using the regular styles, using the default styles, it takes 24 seconds. And using the read-only styles, we typically get maybe 20% improvement, 10 to 20%, depending on the setup you have. So here, wow, we got From 24 seconds to 18, that's an improvement of 6 seconds, which is 25%, which is not bad at all. For such a heavy screen to be able to improve performance by 25% is no small feat. And the number of UI elements always has the biggest impact, simply because it frees up the CLR from worrying about thousands of elements which aren't really needed. You may be asking yourself, why is the XamDataGrid set up with such editors by default? Because in the default scenarios, users want a flexible, customizable grid which they can, which is easy to work with, where by default we have all the editing functionality, all the different elements available for styling. In scenarios where you need extra level of performance, this is where you need to do customizations. This is where, as I said previously, you need to move away from kind of the gimmicks that are provided as part of the product, to give up some of them just to make your life easier, just to give the CLR more time to manage the vast amounts of data which we have bound in this case. So let me go back to the presentation because there is a key element here to mention as well. So the default templates, you can see the number of elements for the different data types. If you have currencies, that's 12 elements. If you have numbers, that's 12 elements. A date time, any date time you have, if you have a date time column, each and every cell consumes 20 elements. So if you change that, the cell value presenter style for that column, for the date time column, you'll be cutting 18 or 17 elements per cell, which is non-trivial. For example, let's say you have a grid which shows 20 rows on a screen. You've just cut 350 elements, more or less, and that's significant for the CLR. So instead of these default templates, use the lean templates for read-only columns. All of these templates are available on my blog, and actually, just to illustrate this, we very often get requests for grid lines, for a lean template with grid lines, and whoops, actually, this one, for some reason, maybe I've renamed something. Let's give it a second try. Either way, this is something that's already on my blog, and yeah, let's try it again. Oh, okay, works this time. So yeah, this resource dictionary is the read-only lean dictionary which contains grid lines, because a lot of users like to see their grids just like Excel with grid lines. So this is a style where we've provided as well for free as part of one of my blog posts, and there is a link to it at the end of this presentation, so you can download it quite easily. All right. So back to our presentation. So yes, the read-only templates I mentioned earlier dramatically cut down the number of UI elements. Currencies, instead of 12, visualized with 3 elements. Numbers, date times, all of them shown in 3 elements. The key takeaway here is that these are all read-only. So if you have editable columns, they won't be editable anymore once you apply these lean editors, because they visualize the data with a simple text block. There is no editor functionality whatsoever. You can download the read-only templates here at this link, and this is also available at the end. I will post this presentation on my blog, and you'll get a link to my blog with the follow-up mailer simply because you registered for the webinar. So you can get your hands on this quite easily. Something very important when you're using these read-only templates, and any template which you code yourself, is to set the allow cell virtualization and force cell virtualization properties to true. It's very important to set these properties on the fields where these read-only templates are applied. So I'll now go a bit into what the force cell virtualization property does. So when you're using your own cell value presenter with no editor inside, like we are right now, we're using a cell value presenter with a single text block. There is no editor inside. So when there is no editor inside, the XamDataGrid instantiates the cells in this column because it doesn't really know what to expect in terms of sizing. It doesn't really know whether the template you have will not cause the row to expand. And this is why, imagine you have a grid with 5 columns visible and 5 columns off screen. So the 5 columns off screen are templated using your read-only style. But the grid doesn't know whether the values in these columns may not result in the row getting taller, right? If they have a size larger than the cells which are visible. So that's why the grid by default instantiates those. So you need to set the ForceCell Virtualization property to true to tell the grid that these cells which are off screen, which are templated using your own template, that they will not cause the row to get any bigger. So the grid can be safe to assume that the row height as determined by the cells in view will not be changed by the cells out of view. So you're basically telling the grid not to worry because you will not be providing content that's any bigger than the one that's provided in the visible cells. And this is very important because if you don't set the ForceCell Virtualization property, all the cells which are not visible will still be instantiated. And I can very quickly demonstrate this, the effect of the ForceCell Virtualization property. So we have a sample here. It's a very simple example of using the grid. I've got a view here. I've bound to some data. Currently, we have ForceCell Virtualization set to true. Let's remove it. That's as good as setting it to false. So what I'll do now is I'll run my sample, and I will benchmark its performance in terms of scrolling. Right. Okay. So we're maximizing this. We have a screen full of data. So we're now benchmarking the scrolling speed. You'll be able to get this sample as well. You'll be able to benchmark the speed of your own grids quite easily. What this does is it runs 5 times just to make sure we're not getting any effects due to the OS doing something. Because this is a quick and dirty performance tests. Typically, we do these on dedicated machines where we can be sure that there is no background tasks interfering with currently running process. So just one more pass really. You can see the time is the complete scrolling time is around 9 seconds 61. We're using the read-only template here, and what's happening is ForceCell Virtualization is not set to true. So all the columns here on the right, they're all instantiated and they're all managed by the CLR regardless of the fact that they're not visible. So when we're scrolling, all of those cells get measured and arranged as well as the ones we see. So that's a huge waste of resource there. So we've got 9.3, an average of 9.3. Now I'll set the virtualization back to true, and hopefully we'll be able to see the effect, even though this is a rather quick and dirty performance test. So the average was 9.3 seconds, and now you can maybe see there is a slight improvement even on the first one. Yes, the average was 9.3. Our first try is 7.2. So you can see we've got maybe 2 seconds. The first 2 tries are faster than nearly 3 seconds faster than the average of the previous setup. So you can see the dramatic effect that the ForceCell Virtualization has on performance when you have columns which are not visible. So we improved it by, yes, almost 3 seconds on average. So that's an improvement of 30% relative to the time we started with. So anytime you use your custom templates, anytime you use the read-only templates we provide on our website, on my blog, please set the ForceCell Virtualization property, because otherwise you will not be able to take advantage of the performance gains. And of course, you can set the ForceCell Virtualization property on the separate fields or on the field layout, on the field settings as a whole. In my case, I have it set on the field settings level, and they apply to the whole field layout because all the columns I have, they're all styled with the read-only style. So I can set this on the entire layout level. But let's say you have some of these columns editable, you can set the ForceCell Virtualization on each of the columns which are read-only and where you've set the read-only cell value presenter style to be used. You want to make sure that these columns do not have their cells instantiated, and this is what the ForceCell Virtualization does, and this is why it's so important. Right. Okay. I demonstrated this sample already. We compared the times before and after with the default templates and with the high performance templates. We noticed there's a 25% improvement. Setting ForceCell Virtualization is a key component of that. Unless you set this property on the columns, on the fields where you're using the read-only templates, you will not see any performance improvement. So this is very important. Right. So much for optimizing the UI side, for reducing the number of UI elements. We'll now talk about how to process your data as far as possible from the UI, and I'll show you some of the allowances we've made to make that easy for you. So by default, let's say you have a XamDataGrid bound to 10,000 records or even 2,000. By default, the XamDataGrid does sorting on the UI thread. So let's say you've bound your grid to 5,000 records. The grid instantiates these records lazily. It only shows you the records. It's only loaded the records it's actually showing. All the other records are hollow objects. They're lazily loaded. They're not loaded from your data source until the user actually starts scrolling or paging or starts doing anything else. So what happens when you scroll is the grid needs to retrieve all the objects and needs to load them all into data row objects, which is the internal type which the XamDataGrid uses to manage rows. So it loads all your data into the UI, and it sorts it on the UI thread. This is something you definitely don't want unless you're okay with a slight delay. I don't mean to cause any alarm here. Most often, this delay isn't really visible. It only starts being visible when there's thousands of records involved. So if you have 10,000 records and if your users sort and would like to have fast first-time performance in sorting, it's much better to avoid the default sorting functionality. So if you make no changes to the way the grid is set up, all the sorting, grouping, and filtering are done on the UI thread, and this causes the grid to load up all the records from your data source. So as you can imagine, this causes a significant loading delay. So the user clicks the button and has to wait for a few seconds, and it substantially increases the memory footprint of your application because your entire data source is now loaded in XamDataGrid objects. And you don't really need that because you're only showing 20 or 50 of those at a time. So how do we work around that? In the 12.1 release, we added API to enable you to do grouping, sorting, and filtering on the list collection view and also manually. So what do we mean by that? There's API that you can use to set the mode of computation. And this is a big improvement, especially if you're dealing with tens of thousands of records and you need to sort or filter those very quickly. You can create an entire middle tier of your application to do just that, and you can have the grid as a simple presenter, just showing the data that's already processed on the back end. So how does this work, and what's the API? There's 3 new properties we introduced: sort evaluation mode, group by evaluation mode, and filter evaluation mode. So all of these you can set to auto. Auto is the default. It's everything's happening on the UI thread, which is not ideal, especially when you have large amounts of data. Use collection view. This basically relays all the sorting, grouping, filtering commands you enter down to the collection view, which does all the heavy lifting and returns a modified view to the XamDataGrid to bind to. So this is much more effective, as you can imagine. And manual. The manual mode essentially fires the record filter changing and changed events, but does not process anything on the grid. So if you have any backend system which is capable of interpreting expressions and which is dedicated to computing data sets, to filtering, sorting, or grouping data sets, this is an opportunity for you to use that. We also have a modified way of computing summaries. You can have them computed on the UI thread, which is the default, or you can compute them manually. Let's say you have them pre-computed from somewhere, or or these are delegated to a separate system, or you can use Link, which of course makes use of a parallel processing. So let's illustrate this effect of external sorting very quickly, just to give you an idea of the kind of impact this has. So I have a sample here, which you can also get from one of my blog posts. Maybe in the biggest way you can see this difference in these 2 examples here. So we're binding a grid to 100,000 items just to demonstrate the big impact this has. So the grid is now bound to 100,000 items, and I'm going to sort. And we're timing this sort. You can see the UI is frozen, nothing's happening, the mouse is moving, but the grid took 4.6 seconds to respond. So all of the data, all the 100,000 records are now loaded into the UI, and the grid can sort very quickly. So you see second time scrolling performance is 1.3 seconds. So 4.6, then 1.3, then it's even faster because yeah, it's around 1, because all the records we need are here already. They're all in the UI. They're all managed by the grid. And this isn't exactly ideal, especially if your users care about first-time performance, or if you don't want to increase the memory footprint of your application. So in the second example here, we have 100,000 records bound to a grid which uses the external sorting and filtering and grouping. So what I'm going to do is I'm going to sort here again, and we see the first time performance is 1.83 seconds. So that's half of what the previous example showed, because in this time we're not loading all these data items to be sorted by the grid. They are sorted in the underlying list collection view. However, as they're not being loaded and the memory footprint remains constant, we're not loading any additional objects in the form of XamDataGrid rows, this is the sorting time you will see each and every time, because this is the sorting which is done by the list collection view. You can see there's a more or less a stable 1.8, 1.9 seconds period for sorting to be applied. So it's your choice really. With this approach, with external sorting, grouping, and filtering, at least using the list collection view, we get a time of 1.8 seconds and a low and constant memory footprint. With the previous example, you get a hit initially of about 4.3 seconds, a greatly increased memory footprint, and from that point on, subsequent sorts are quite fast. You can see 0.9, 1.2. It's not that much faster, but it's maybe 70% faster than the optimized one. However, it's up to you to choose whether you want to make the trade-off of space versus time, whether you want to preload all the records and take an initial hit and then enjoy fast sorting times, or you want to see constant, if not best, then at least manageable sorting times and a low memory footprint. So this is API we've introduced in 12.1, and it's well documented, and of course you can this external processing, as I mentioned, is also applied to filtering and grouping as well as sorting. So you can improve the speed of those operations on large data sets as well. Right, and back to our presentation. Sorting real-time data. Let's say you have updates coming into a grid and the grid is sorted. Previously, before 12.1, sorting was applied on the whole grid, regardless of whether the column which you had sorted on had changed, because there was no way to find out if it's the column, if the column that changed was the column you've actually sorted on. In 12.1, we actually added API which lets you do that, and I'll now very quickly bring up an example just to demonstrate that. Because using this API, you're able to tell whether the field that you're sorting on is the actual field that's changed. So I'm just loading this this sample now. Okay. Right, here we are. Okay, so I'll run this sample, and it shows a grid which is updated. The backend is updated, and this is the difference in the number of sorts depending on whether you're using the old API or the new API. With the old API, we're invoking the sorting 7 or 8 times more compared to the number of times we're invoking it with the new logic. Why? Because we have a few different groups here. We have maybe 3 or 4 groups. We're modifying the values of all of these columns, but the sorting needs to be refreshed only if the group me column changed, because that's how the sorting is applied. So using this API, you're able to significantly cut down the number of sort invocations on the XamDataGrid, and this is again illustrated in an example on my blog post, and you can download it very easily. There's a link to it at the end. So this is why I won't show you the source code. It's much better to just proceed to later examples. Right. So how do we perform formatting away from the UI, and what effect does that have on performance? When you format the data in the UI layer using converters or data template selectors, there is always a price you're paying. This is why we're recommending, if you want to squeeze out extra bits of performance, to format data in the application layer and to bind to the format values. And I also mentioned the unbound columns case where ideally you shouldn't be having unbound columns. If you have performance issues, move the computation of those unbound columns to the view model and bind to that computed column in your view model just as if it's one of the regular columns. So the grid doesn't really have to spend the time invoking converter logic when the user is scrolling. That's when the grid can focus on the actual measure and the range of all the cells which it has. As I mentioned earlier, converters are evaluated for each and every cell scrolled into view, so you definitely want to avoid that. Styling. This is a very important point. Very often developers use triggers, and they bind to different properties of an object in a cell to find out what kind of coloring they need to use for that cell. The problem is that for each of these triggers, you're having a separate binding, and bindings are slow in WPF. So instead of having multiple bindings and triggers, so instead of having 3 triggers which have 3 bindings, it's much better to evaluate this condition on the view model level and to set the appropriate brush on a property of the bound object. So we can directly bind, so the brush you have in the style can directly bind to a property on the bound object, and that will give you the correct brush at the price of a single binding instead of 2 bindings. And we have an example here. So take a look at these 2 styles. So the style on top, we've got a background setting which directly reaches into the data item. This is how you get the bound item in a cell. This is a data item, and it directly gets the brush from this property, row background color. So this is already computed. This is all done on the view model level. The next style is the less efficient one. We have 2 triggers here. They're both looking at different properties of this object here, and they're setting certain colors. So here we have 2 bindings, and we could have simplified that. We could have extracted this logic. We could have basically compared the value of this property at the view model level, and we could have set a brush to a property which is then bound with a single, at the cost of a single data binding here. So, of course, we're nitpicking here. This is taking things to an extreme, but keep in mind, we're talking about styling based on cells. And when you have a 30 by 30 grid visible on screen, such as the ones I showed you, this definitely adds up. So depends on the scenario, but this can give you anywhere from 0.2 seconds to 0.5 second maybe. This is entirely up to the scenario. But as you know, every little helps when you're pursuing better performance. So far we've covered general ways to make your WPF applications faster by the way you structure your UI, by the way you declare and use your resources. We've also talked about the XamDataGrid and how to make it run faster. One way was to cut down the number of visual elements. The second way was to do as much processing formatting at the view model level instead of at the UI thread. And the third one was to offload all the data processing such as filtering, sorting, grouping on the view model level, on the list collection view, or in a manual mode on a different machine altogether using the API I presented. So another key concern for WPF developers we've seen is the speed with which their views load. So you very often have views which load for 3 or 4 seconds simply because they contain the ribbon control, a docking control, and a grid control. So how do you improve loading times? One of the biggest reasons for the slow loading time of screens which contain sophisticated controls is the fact that the CLR needs to reach out to the library. It needs to instantiate this control, resolve the DLL, load the DLL, JIT compile the DLL, load all the themes. So you can imagine this takes time. It's a single hit. You only do it once in an application. The first screen that a user opens containing sophisticated controls, they're loaded up once and they're kept easily accessible for all subsequent invocations of the same view or other views using these controls. However, very often you want to have a fast first-time performance. So how do you make sure you have quick initial loading times? You preload the controls. So what do I mean by that? You create a separate form where you place all these sophisticated controls, which you open prior to opening the first form that the user sees. Very often, in applications, when a user opens the application, they need to sign on. You need to establish connections to databases. So all these things take time, and very often that's not time that's spent on the UI thread. So what you can do at that stage is you can create a preload window, a separate window that you open somewhere out of the visible area of the screen. Let's say at X and Y 50,000. So it'll never be seen by the user, but it will force the CLR to load the DLLs, to resolve the references to themes, to JIT compile the controls. So they will be ready, they will be preloaded the second time you need them. And the second time you need them is when you'll be showing your main application screen. So when the user clicks show me the list of customers, the XamDataGrid or any other control really, it also applies to the Microsoft grid controls, any control altogether. This is a generic approach to improving the initial loading time of your application. So how do you do that? It requires a change in your application initialization logic, and you need to document it well, simply because it's such a bizarre thing to see. For anybody else who's not familiar with what you're doing exactly, they would be wondering, why are they loading some controls in a window that nobody ever sees? So let me illustrate the effect here using a sample. So let's see, I've got in app XAML CS, I have some code which opens a startup window. So on startup, I'm instantiating a preload window. I'll show you what the preload window looks like. Its startup location is set to manual. It appears at some pretty far away location. It's not shown in a taskbar. It's shown and then it's closed. So that's all really. So there's nothing really complicated here. And let me just show you what the preload window has. It has just a simple grid, which is bound to some sample data to make sure that columns and rows are also visible, that cells are visible, that all these types get loaded, resolved, and are ready for quick use the next time they're needed. So let's compare the times. So we're now running this without preloading. I've set the is preloaded to false, so this code is not executed. And now I'll bind to a list control. I'll launch a separate window. When I click on this button, I'll launch a separate window which contains a grid control. So you can see I clicked and it took a while. So it took nearly 2 seconds to load and render. So you can see the way we measure this over here. So we're doing this with a stopwatch, and we're essentially taking the time before and after this window is shown. So Without the preload, it takes nearly 2 seconds for the screen to appear, and you probably saw that delay as well. I think it was visible this time. So let's set it to true. I'm quickly running the sample. Right, okay, you didn't see any delay to begin with. We're binding to list, and we see our window pop up immediately. We have an improvement of nearly, yeah, so from 2,000 milliseconds to 200 milliseconds. So that's an improvement of 90%. So that's not bad. And the user believes that our application is super responsive because the second they clicked the button, they were able to see the grid bound to the data immediately. So, as I said earlier, document this approach well to make sure that your colleagues don't get rid of it very quickly, causing a degradation in performance levels. This is a list of all the demos I used in this presentation. I will post this slide deck online on a blog post, and you will be sent a link to it with a follow-up mailer. So these are links to samples I used in this session. So you can download all of these, you can play with the source code, and everything is explained on the blog posts themselves. So with that, thank you very much for your time. I'd be happy to hear from you. This is my email. Of course, you can always open support requests with Infragistics, but I'm also available if you have any questions. So with that, we can open the session for questions now. I will try to respond to all the questions which you ask in the chat window. But even if you don't think of anything right now, you can always contact me over email. I do hope this was useful, and Infragistics has always been committed to pursuing performance as a core aspect of our controls. So if you have examples where you find performance lacking, you're more than welcome to let me know, and I will help you. Okay, I'll remain on the chat and try to respond to all of your questions. I will provide this slide deck on a blog post, and you'll receive a link to it so you can download the slides and all the samples. So with that, thank you very much, and I will stay in the chat room responding to any questions you have.